Hey guys, if you're in Trig, this is a continuation for 7.6, and if you're in Pre-Cal, this is a continuation for 6.6. We are continuing to talk about vectors. So last video you saw what a vector was, the vocabulary that went with it, how the equations look like, and how to find its magnitude, the basics, okay? So now we're going to start doing some math with these vectors. The first thing we're going to do is very simple, and it is operations with vectors, okay? So although vectors have i's and j's, I want you to pretend like if it was an equation with x's and y's. It works the same way, okay? So if I have two vectors, right, given, and I want to add or subtract them, all I'm going to do is combine like terms. That means if I'm adding, I'm going to add the two i's together and add the two j's together. If I'm subtracting, then I just subtract the two i's and subtract the two j's. If I am multiplying a number to a vector, it's like if I were to say 2 times a function, you're just going to distribute that 2 to both the I and the j. Okay, very simple. I'd even suggest you trying them without me. Pause the video and then check back in, okay? So here is vector v, 2i minus 3j, and here's vector w, negative 1i plus 4j. So if I want to add them, I'm going to say 2i minus 3j plus a negative I plus 4j. Okay? And if I'm combining like terms, I'm just going to combine my i's and then combine my j's. So 2i minus 1i is going to give me 1i. And then a negative 3j plus 4j is going to give me a positive 1j. And we're done. Okay? Let's look at the next one. The next one has subtraction, and just like in early algebra, you have to make sure that that negative gets distributed to the w. So I'm going to write this one a little slower. Let's write my 2i minus 3j, okay, that's my vector v, minus my vector w. And then now I have to distribute this negative. And then I'm just going to rewrite it really quick. Two negatives make a positive and a positive make a negative. And now I can combine like terms. So I have 2i and 1i, which makes 3i. And then I have negative 3j and a negative 4j, which makes a negative 7j. Okay. All right, hopefully you're doing good so far. C is 2 times vector v. So I'm going to get 2 and multiply it to the entire vector v. Just like I did with the negative, I'm going to have to distribute. Okay. And I can say that this is 4i minus 6j. Okay. Next one says negative 3 times vector w. So I'm going to say negative 3 times my vector w is negative I plus 4j. I need to distribute that negative 3. That gives me a 3i minus a 12j. All right? If I'm going too fast, please feel free to pause the video, rewind as many times as you need to. All right? Let's look at E. E has 2 parts to it, okay? It has 2 times v minus 3 times w, okay? So I'm going to write one at a time. I'm going to say 2 times v minus 3 times w. Okay, so 2 times, here's vector v, minus 3 times vector w. I'm going to distribute that 2, and I'm going to distribute that negative 3. Okay, we end up with 4i, okay, minus 6j plus 3i minus 12j. All right, and now at this point is where I can combine like terms. Here is my i's, which is going to leave me with 7i, and then I have my j's, which is going to leave me with negative 18j. So many of my students, when they first try this problem, they get it wrong because of a very silly mistake. They think to themselves, hey, I have the answer of 2v, and I have the answer of negative 3j. Excuse me, negative 3w. So they take these two answers and they subtract them. So the mistake that they're making there is that they're using the negative twice, because they already used the negative here in their answer, and then they use it again when they subtract. You could use these two previous answers as long as you take into consideration that you already used the negative here. In that case, it would mean that you would have to add them. But again, I'd suggest that you just go step by step, because in a normal like homework quiz or test, you wouldn't have taken those baby steps, okay? All right, let's take a look at our next operation, okay? Our next operation is called finding a unit vector. A unit vector is a lot like a unit rate, which you learned back in middle school, okay? Some real world scenarios of a unit rate that you can think of, beats per minute when your doctor takes your pulse. Remember, you take, let's say he measured for 2 minutes and he got 120 beats, it would be 60 beats per minute. You take it down to 1 unit. That's a unit rate. Another one is when you're driving 70 miles an hour. Yeah, maybe you didn't drive for an hour, but the unit rate is taking it down to a measurement of 1 hour. And maybe when you pump your gas, you say, gas cost me $2.50 a gallon. Yeah, you didn't put 1 gallon in only, but the price is given to you as a unit rate, okay? So we're doing the same thing for the vector. We're finding it regards to 1 single unit, okay? Very easy formula. And it is the actual vector divided by its magnitude. So step 1 is going to be to find the magnitude. Step 2 is going to be to divide the letter A by that number and divide the letter, or the number, I'm sorry, B by that number, okay? So let's look at this first example together. Then I'm going to encourage you to pause before I do this one so you can try it on your own, okay? So the first example says find the unit vector in the same direction as vector v. So again, we said step 1 was to find the magnitude. This is in standard notation, very easy, just Pythagorean. The a squared plus the b squared. All right, so we end up with square root of 9 plus 16, which gives me square root of 25, which cleans up to 5. So now I can say that my unit vector, and I write that notation like this, is equal to negative, I'm going to get the a value, negative 3 over 5. I'm going to write my I, minus 4 over, right, I'm dividing my magnitude, 5j. And that is my answer. Let's check out the next one. Again, I encourage you to pause, try it on your own. Find the unit vector in the same direction as this vector v. Step 1, find the magnitude, which is my a squared plus my b squared. Okay. And if you put square root of 169 in your calculator, it is a clean root. It gives you 13. Okay? So now my unit vector, here's my notation on how to write it, is equivalent to A over the magnitude I, and then I have my B is negative, so minus 12 over the magnitude J. So let's look at our next thing to do. In the past few lessons, we've been talking about consistently converting back and forth from polar to rectangular, okay? We did it with regular numbers when we first started learning polar. We did it with our complex numbers when we did a plus bi. And now we're going to do it to our vectors, okay? So hopefully it should ring a bell that anything polar has thetas in it, okay? So let's look at this left side, okay? This left side is my vector in rectangular form. What we've been talking about, I'm sorry, right here, this entire time, AI plus BJ. If I want to get to my A and my B, but I was given the information in polar, then I would multiply the magnitude by cosine or sine, according to if it's A or B, of theta. Now, if you're in my pre-cal class and you feel like it's a little overwhelming to memorize so much, you have technically memorized this formula several times, okay? We learned that A and B, or X and Y, was R times cosine of theta, okay, where R was the square root of X squared plus Y squared. And if X and Y are the same as A and B, you should realize that R and magnitude square root of X squared plus Y squared, or A squared plus B squared, is the same thing. Okay? So this formula, you've seen it. This is the third time you've seen it in this chapter, just with different notation. Okay? Now, if you want to write this in polar form, okay, you would just plug what A equals, right? The magnitude times cosine of theta, in the spot of A in front of the I. So if you can see, the A is equal to magnitude times cosine of theta, and B is equal to magnitude of sine of theta, and then you just have the I's and the J's, okay? If I ever needed it in polar form, I would grab the A and the B to find magnitude. And then remember, we always find theta. This is old news, inverse tangent of B over A. Again, these four formulas you have seen for the third time in this chapter, okay? Now, one very important thing about theta. Whenever you use theta, it has to be in standard position. Standard position means that it goes from the origin, if you think of your unit circle where 0 is, and then towards, counterclockwise, that value. So many times information is given to in bearings, and your job is going to be to convert that bearings. So let's look at these two scenarios before we actually see the conversion of the vector. If they told me north 45 degrees west, okay, I would need to draw that. So I would go from north 45 degrees towards west, but to have it in standard position, I would need to figure out what this angle was, okay? Now, if I need to add an entire quadrant to it, what I'm really doing is 90 plus the 45 degrees, okay? So we end up with 135 degrees, and that would be the theta that we're going to use for these problems, okay? Standard position. So if I look at this next one, if I want to go from standard position to that value, I would need to say, okay, if I'm in quadrant 3, I need to say all of this would be 270, which is down here, right? Minus that 40. Okay, and that gives me 230 degrees, and that would be the theta that I would use in this scenario for this problem. Okay, so that's just a quick little refresher. Let's look at what a full question looks like. It says the wind is blowing at 16 miles per hour towards north 60 degrees east. Express its velocity as an ij vector. Okay? Now, velocity has to do with some sort of a force, some sort of a push. So they're talking about here the force, the quantity, being that 16 miles per hour towards, and then here's our direction. So hopefully you start to see the information for our vector. Here we have the magnitude, and here we have the theta. So like the car that I told you that was going 50 miles an hour north on the highway, same thing. Okay? So the first bit of information that we have here, let's look at theta. Okay? So this went north towards east, and it went 60 degrees, which means that my job is going to be to find this value. So the first thing I have to do is say, okay, 90 minus 60 is going to give me 30 degrees. This is going to be my theta. Okay, so I have my theta and I have my magnitude. Magnitude is 16. Let's write that down. Magnitude is 16, and theta is 30 degrees. Do you think I have the information in polar or in rectangular? Hopefully, seeing that you have a theta given, you see that you can plug in the magnitude and the theta, and you can find A and B, which means it was given in polar, and now you can write it in rectangular. Oops, sorry. You can see that you were given the magnitude and the theta, which means you were given the problem in polar, and you can write it in rectangular as an ij unit vector. Okay? So I'm going to say, according to my formula that we had just written down, vector v is equal to the magnitude. Let me rewrite the formula. Okay, so now I can say 16 times cosine of 30 I plus 16 of sine of 30 j. Okay, now I'm going to go to my unit circle for sine and cosine of 30, so I can say 16 times square root of 3 over 2 plus 16 times 1/2 j. Okay, so my vector and my final answer is 8 square root of 3 I. All I did was reduce the 16 with a 2. Plus, I'm going to reduce the 16 and the 2 again, and it is 8j. And that is your final answer. All right, so I encourage you to take a moment to try this one on your own. Go ahead and pause the video. It says the wind is blowing at 20 miles an hour towards north 30 degrees west. So I'm going to start by drawing my north 30 degrees towards west. Okay, so the angle that I want is from standard position, meaning from the origin, over to that point. So that means I'm going to say 90 plus 30, which gives me 120 degrees. So I have up here my magnitude. It's blowing at 20 miles per hour. And then I have my theta, which is 120. Okay? So my vector, I do magnitude times cosine of theta. Whoops, put a j. Times cosine of theta I plus magnitude of sine of theta j. So my magnitude was 20 times cosine of 120 degrees I plus my magnitude, which is 20, times sine of my theta, which is 120 degrees j. I'm going to go to my unit circle for cosine of 120 and sine of 120. So I have 20 times negative 1/2 I plus 20 times positive radical 3 over 2j. Okay, so half of 20 is 10, so I have negative 10I plus half of 20 is 10, radical 3j. All right, let's take a look at this last style of question. Very similar to the last one. I'm just going to up the level of difficulty a little bit. This is definitely a type of question I like to challenge my pre-cal classes with. So let me just give you a scenario really quick. Let's say I grab the chair next to me and I lift it up, okay? In reality, we have multiple vectors at play at one time. So for example, the force of my arms pulling the desk up creates a vector going upward, okay, where the magnitude would technically be my strength, so to speak. And then we also have the weight of the desk creating a vector going downward, okay? So there's that friction, that opposite direction, okay? So when I take into account both vectors acting at the same time, we call that a resulting vector or a resulting force, okay? It's the result of both of them put together. So in this question, I'm going to give you two vectors that are happening at the same time, and then we're going to find out what the resulting force looks like, what its magnitude, and what its direction looks like, okay? So if we read this question, it says two forces, F1 and F2, of magnitude 5 pounds and 12 pounds act on one object, okay? The direction of force 1 and force 2 are north 20 degrees east and north 75 degrees east, okay? So let's take into account that both of these are in order, okay? So the 5 goes with the first one, the 12 goes with the second, and then this north 20 goes with the first force, and then north 75 goes with the second force. It then says, find the magnitude and direction of the resulting force. So that means that the first thing we have to do is be able to find the resulting force. So we're going to call that like the resulting vector, okay? So in order to combine my two vectors, I first have to create my first two vectors, okay? So let's do exactly what we did on our last question to create each of the two vectors, okay? So we're going to create F1 first, okay? F1, we're going to draw, here's our bearings. It's going to go north towards east 20 degrees, right? So our job is to find theta in standard position, which would be 90, let's draw a little box there, minus 20, which gives us 70, okay? So for F1, let's do a double underline. So F1 has 5 pounds is my magnitude. And instead of putting a V, I'm putting F1. And then my theta, we said, was 70. Okay? So now we said my equation for a vector is magnitude, which is the same formula we wrote last time, okay? And I'll write it one last time here. So we're writing 5 times cosine of 70 plus 5 times sine of 70j. Now, being that 70 is not on my unit circle, I'm going to go ahead and go straight to my calculator. If I'm putting 70 degrees, please make sure that your mode is in degrees, okay? So this will end up giving me 1.0 4.71I plus 4.7J. Now let's take a moment and do the same exact thing for force 2. Again, if you're feeling confident, I encourage you to do this. Pause the video and do it on your own. So I'm going to do a squiggle for F2. Has 12 pounds. Oh, I forgot to double underline here. Okay. All right, so the one that we need here, again in standard position, so we're going to do 90 minus 75, and that gives us 15 degrees. So for force 2, if we look at my swivels, I have that my magnitude is 12, and my theta is 15 degrees. Okay? So then we're going back to the same exact formula. So I could say vector V is the magnitude times cosine of 15 degrees I plus the magnitude times sine of 15 degrees J. So again, 15 degrees is not on my unit circle, so I am going to go straight to my calculator for this. And it's going to give me 11.6 I plus 3.11 J. Now for the next part, the resulting force. So let's make a little side note. We found force 1 and we found force 2. So for my resulting force, okay, same as resulting vector, I'm just going to add my two vectors together. So I'm going to say F1 plus F2. Okay, so in order to get F1 plus F2, I'm going to add these two together. 1.71 I plus 4.7 J, and then add it with this vector, 11.6 I plus 3.11 J. Okay, and we are going to combine like terms. So here's my I's and here's my J's. If your decimal ends up being a little different than mine, maybe because you use more decimal points, which is a good thing, that is totally okay. All right, don't let it freak you out. So when I add those two I's together, I end up with 13.31 I plus, adding the J's together, 7.81 J. Okay, so this right here is my resulting vector. Now, this question said, find the direction and the magnitude of this resulting vector. So, if I want to find the magnitude of this, now I'm going to do the magnitude of this vector. So I can say square root of 13.31 squared plus 7.81 squared. And feel free to take your calculators out for this, okay? You should end up with 15.58, and if we look back at our question, it said that our units was pounds. Okay, so we have our resulting vector. We have the magnitude of that resulting vector. And then we have left to find the direction. So I can find theta, okay? Remember, theta is inverse tangent of B over A. Okay? So I can say inverse tangent of my B, remember B is the one next to the J, divided by A. We need to be in degrees mode. And when you plug that into your calculator, you should get 30 degrees. All right, so we did round that. This is not my final answer, though. They are asking for a direction. Direction implies bearings. They want north, south, okay? So what I'm going to do is I'm going to draw this. I'm going to scroll up a little bit. And if I wanted 30 degrees, bearings travel starting from north or south. Since I'm in quadrant 1, I would go from north towards east, and I would have to find out what this value is. Okay? So that value is going to be 90 minus 30, which gives me 60, which means that my direction would be north 60 degrees east. So there are my three final answers. I have my resulting force, which is this vector. I have the magnitude of that resulting force. And then I found theta to help me find the direction of that resulting force. All right?